Welcome to Season 3, Episode 4. Today we're going to talk about biomimetic dentistry, which obviously is the topic of conversation for the Six Lessons podcast. But in the first 3 episodes of this season, we have talked about minimally invasive dentistry, how important that concept is. And we talked about adhesive dentistry and cosmetic dentistry, which are often, obviously, intimately connected. But today, the idea of biomimetic dentistry is going to be our topic because the difference between biomimetic dentistry, which is minimally invasive, and biomimetic dentistry that is adhesively dentistry based, and biomimetic dentistry that actually makes teeth look pretty good, and it could be referred to as cosmetic dentistry. In my mind, they're all separated, and the separation is based on bond strength. And so the bond strength that most dentists think about is the bond to enamel. And many, even key opinion leaders, have always said, if you have an enamel rim, then you're going to have success. In other words, if you're bonding to a restoration that has enamel etching and bonding 360 degrees around any defects that are deep, then you'll have success. That's very true. But the difference with the biomimetic approach that I developed was that I am saying dentin bonding is more important than enamel bonding. That's pretty radical. Nobody else went there until I went there. Now a lot of people are going there. But why do I say that? Being a dentist of 44 years, I've seen a lot of teeth in a lot of different conditions. An ideal tooth has a hard outside and a soft inside, enamel and dentin. But I, facetiously sometimes say, if God only had one choice, it can only make a tooth out of enamel or dentin, what would the choice be? And I know from my own experience, a tooth that has dentin has the ability to withstand fractures. But once the fractured enamel happens, that fracture has to be cushioned by the bottom. And actually the connection of the bottom part of the tooth, the dentin, is twice as tough as enamel. So if you only had a tooth that was made out of enamel, one good bite on it might take the whole thing out. Where if the whole tooth was made out of dentin, it wouldn't be quite as resistant to chewing forces and you'd wear more. Enamel in a natural tooth wears about 11 microns a year. Dentin about 50 microns a year. Well, in the long term, or in a biomimetic approach, in my 6 lessons approach, dentin is more important than enamel. Now, enamel is important. It gives durability, much better under occlusal forces, makes the tooth whiter. Most people like whiter rather than yellower, all those kind of things. But years ago, Pascal Magne and I had a discussion about aesthetic dentistry, which he's a very popular speaker for aesthetic cosmetic ideas. But in reality, we came to the conclusion if the best we could do is put a green top on the tooth and all of our biomimetic teeth were green, we would still say the best way to restore a tooth is biomimetically, even if it didn't look good. Obviously, this is facetious talking just to make a little joke out of the idea that cosmetic dentistry has its place, but biomimetic dentistry is all about using the dentin as the standard of making the foundation of your restoration. And so Pascal, when he speaks around the world, his signature lecture is about immediate dentin sealing. It took a long time to have people understand that when you talk about immediate dentin sealing, you're not talking about immediate enamel sealing. You're talking about dentin sealing. If you don't have any dentin, you don't have to do immediate dentin sealing because there's no dentin. I mean, I'm trying to not be sarcastic. I'm getting old, so you have a tendency to be a little cynical of people who haven't quite given you the respect that you think you deserve. But in reality, it's very, very important to understand the potential bond strength of dentin is twice as strong as the bond to enamel. Because if you bond to dentin and then you try to pull that restoration off dentin, there's a little bit of give here. But in enamel, if you bond to enamel, there's no give in the enamel. It's brittle and it can fracture at 25, 30 megapascals. But dentin to itself will be connected at around 40 to 50 in all parts of the dentin. And those 40 to 50 numbers are what we can achieve when we have a biomimetic restoration. And so our definition of biomimetic dentistry that we teach in the 6 lessons is do the restoration that will keep the pulp alive. Why is that so important? Because the pulp hydrates the tooth, the dentin. If it's not hydrated, it becomes more brittle. It's like everyone has seen a tree that has lost its vitality. That vitality loss means that the thin layer of moisture that is between the bark and the inner parts of the tree has been lost, and so there's no moisture in the whole length of a tree. If you kill a tree by stopping that moisture, and that's called girdling a tree, you can make a strip of bark taken off 360 degree on a tree, and all of a sudden the moisture that comes up from the roots stops at that place where you have made the girdling, and the moisture doesn't keep pushing up into the branches and even the leaves to give the leaves moisture that it needs. Well, those trees are 3 times as likely to go out in a strong wind because they become brittle and they're not tough. And that's the same thing with the tooth. A tooth that does not have moisture from a pulp is 3 times as brittle and 3 times greater chance of fracturing, particularly in the roots. And so first thing, keep the pulp vital. Second thing, the definition in 6 lessons is to preserve critical tooth structure. Now, we don't just say tooth structure. Minimally invasive dentistry has an emphasis on all tooth structure being preserved, and we're just taking away small incipient lesions, and those small incipient lesions can be restored many different ways. Many of them are quite simple. A glass ionomer restoration and a minimally invasive preparation that the tooth's web of connecting enamel, the subocclusal oblique transverse ridges, if they're all intact, then the tooth always supports these small restorations. But in a biomimetic approach, those rainy ridges have mostly been destroyed. If you can preserve them, we do. That's critical tooth structure on the top. But the critical tooth structure on the bottom is considered the part of the tooth underneath the height of contour, which is usually 2, 3, sometimes 4 millimeters from the height of contour to the CEJ. Why is that area so important? Because the stress analysis that engineering techniques have done on teeth have shown that there is a difference of isotropic and anisotropic forces. What does that mean? Isotropic forces, when something is pushed on, it squishes. Anisotropic force means you push on the top, the force is transmitted immediately to the bottom. An example is a PFM crown. You push on the top of PFM crown, the forces at the bottom receive that force immediately. If the top goes sideways, the bottom goes sideways. If the top goes the other way, it goes the other way. But the idea is that there is no connection to the bottom of a crown, and so all of a sudden, the bottom of the tooth that is preserved is hypofunctional, meaning it is not supporting the bottom part of the restoration. And so that's a major problem with traditional crown and bridge, anisotropic force distribution. Well, an isotropic situation in the tooth is interesting. The top of the tooth is anisotropic. The bottom of the tooth, below the height of contour, is isotropic, meaning it expands a little bit. So you got the forces come down, and then they get distributed sideways in the tooth. And a very important paper analysis was published. Got to get the date right. I think it's 1998. Let's see if I'm right or wrong. Oh, 1998. And you'll never remember these guys' names because Wang and Weiner. Wang and Weiner. You can't make this stuff up. So Wang and Weiner in 1998, with a very sophisticated engineering test that's called Moire fringe analysis, showed these distributions and how the tooth has this ability to first resist the forces in this anisotropic movement, and then the bottom of it spreads the forces out towards the cervical area of the tooth with this isotropic expansion and contraction under functional chewing. So in the 6 lessons approach, we say conserve critical tooth structure. On the top, it would be the rainy ridges. On the bottom, it would be the portion of the tooth which we have named the biorim. And so with those, we have the ability to create onlays that preserve all of the essential tooth structure. It's very cool. In lesson 5, we talk about that. If you have rainy ridges, keep them. But biorim, you will always have to keep at least 70%, 50%, even 40% in these preparations that we do for onlays, even if they have deep margin elevations, which the biorim has been destroyed. And so in our definition of biomedical dentistry, we have 1, keep the pulp alive, 2, conserve essential tooth structures, and 3rd, connect the tooth side to side, front to back, and top to bottom in 30 megapascals or above. Why do we choose 30 megapascals for our strength? Because that is the cohesive strength of enamel. Enamel very rarely separates under occlusal function. If we can connect a tooth at 30 megapascals, that means it's connected to the restoration at the same force that enamel is connected to itself. It's going to hang together most of the time. Can you get more than 30 megapascals? The answer is yes. But that depends on the condition of the tooth surface. For example, root surface will never get to 50, but root can get to 30 or 40. Superficial dentin, you can get to 50. But quite often our restorations are replacing defects that are deeper than 3 millimeters. So you'll be past the DEJ, a millimeter past the DEJ gets you into the superficial dentin, which gives those high 50s, even 60 megapascals when they're tested. So those are the 3 definitions of biomedical dentistry. Keep the pulp alive, preserve critical tooth structure, and connect the tooth side to side, front to back, and top to bottom in the 30 or greater megapascal range. But when I say that, and people have heard me say that for years, very few really understand what that last phrase that I'm famous for, get bonded, and stay bonded at that 30 to 50 megapascal range. But when I say side to side, front to back, and top to bottom, it's important to realize that in a natural tooth, that connection side to side, front to back, and top to bottom is around a hollow core, which is the pulp chamber. Oh. So the side-to-side connection isn't a direct connection. It's a connection around in what we call the peripheral seal zone. So when I created the concept of the peripheral seal zone, and we wrote the famous paper in 2012, Pascal Magne and I, about the sealability of this peripheral area, and it becomes the replacement for traditional ferrule connections of a mechanically retained crown. And so we call this an internal ferrule sometimes. That was an old concept. We find our old phrase. Now we call it a peripheral seal zone. But the peripheral seal zone, that's the important strength area. If you have less than 30 to 50 megapascals in this completely surrounding area, which we call the peripheral seal zone, and then on top of that, we could also use the phrase that Graham Milicic like of a compression dome. If we look at a dome in architectural constructions, we have a huge, massive area that can withstand the forces of gravity. But the dome is supported around the bottom or the edges of the dome, not from the middle of the dome. So a compression dome can take tremendous forces. Graham Milicic has a slide that I like. I should probably get a copy of it, but he has a race car, and the race car is being supported on 4 porcelain teacups. So under each wheel, there's a porcelain teacup. Car weighs, I don't know, a couple thousand pounds, I think. But the idea is that when you have this dome, you can push on the dome, all the forces distributed around the bottom of the dome, the whole cup is taking the forces. And that's how the construction of a dome can have great mass, but also have a hollow center. And so the compression dome, supported by the peripheral seal zone, these are the structural characteristics of a restoration that we call a biomimetic restoration, which is like a tooth. It mimics tooth. It's like nature. So when we mimic biology, we mimic nature, we mimic a tooth, we have those characteristics of the hard outside around a very soft or non-existent bond in the middle, but under forces, it acts in a way that distributes all the forces and prevents fractures or catastrophic failure of the tooth. Wow. I like to talk about this. I think you can tell, and I'll look right in the camera and say, if you like to talk about biomimetic dentistry, then 6 lessons approach is your way to go, because you will be able to see the details of this science. And when you see the details of the science, then you have the confidence that you're doing it the right way. And if you have consistency in your science, you'll have consistency in your outcome, and you will eliminate most of any of the failures that you've seen in your dental practice, and it's a recipe for a happy dentist. And how do I know that? Well, because we have happy dentists practicing the 6 lessons in 50 countries. In those 50 countries, the spoken languages are in the hundreds. I only speak 2 languages, but let me just read through this list real quick. India, Turkey, Lithuania, Germany, Scotland, England, Hungary, Chile, Brazil, Colombia, Ecuador, Singapore, Malaysia, Indonesia, Iraq, Egypt, Mexico, Dominican Republic, USA, Morocco, Japan, Australia, New Zealand, Venezuela, Bolivia, Canada, El Salvador, Saudi Arabia, South Korea, Philippines, China, Myanmar, Peru, Belize, Italy, Libya, Iran, Kuwait, Guam, Puerto Rico, Latvia, Estonia, Switzerland, Ireland, Netherlands, Uzbekistan, Bahrain, Ukraine, Costa Rica, Moldova, and now with this group that we're just starting last week, we have Georgia, countries where lectures have been given by the Allemans or by masters that we've trained. We have over 500 masters in the world over the last 20 years, and many of them give lectures. But we have also groups now of ambassadors who are very dedicated to teaching specifically biomimetic dentistry using the 6 lessons approach. So it's a very specific partnership that we have with the teaching centers that use our logo, use our materials, and we have the ability to multiply our effectiveness in the world by having more master teachers trained at a high level, familiar with 100 or 200 or 300 pieces of information, which is the firm foundation of the science of adhesive dentistry. This last group, we had the privilege of starting the training of one doctor, a first doctor from Japan. And many people might be surprised, why haven't you had masters from Japan? And the reason is because they, with their adhesive approaches, have solved probably 90% of the problems. If you adhesively restore a tooth early, it prevents the failures of mechanical traditional approaches, and those failures that are prevented mean that you don't have to deal with a deep margin elevation. You don't have to deal with a fracture underneath a cusp that is actually not into the pulp. But anyway, we're having these conversations, and I've had these conversations with Tagami and others, that in Japan, they have cracked teeth, but they just haven't dealt with them. But those teeth in Japan that are adhesively bonded early have long-term successes. But if you have a tooth that is mechanically destroyed with Rainy Ridge destruction early in the technique, which G.V. Black codified in the extension for prevention, which removes these connecting webs of enamel, these subocclusal oblique transverse ridges, then that tooth is at risk for fracture and decay and retreatment. And then the retreatments cause other problems and other risks of future retreatment. Pascal likes to talk about the phrase, the cycle of death or the cycle of retreatment. So 15 out of the 28 schools in Japan that are advanced and have committed themselves to using caries detecting dye and gold standard bonding systems. And if you do that without a biomimetic approach and you have all of the walls in place, no matter how large the restoration, you are going to have a good side-to-side connection. You just probably, because of C factor, will lose your top-to-bottom connection. So if you have a large restoration, but it's connected side-to-side, front to back, but it's not connected as strong on the bottom, under function, the anisotropic aspects of this are still functioning well. And Tagami, for example, showed a case in Turkey 3 years ago that was 40 years old, using a chemical cure early bonding system from Moire called New Bond. It was 40 years ago. It was new. Let me see. Got to get the right date on New Bond. I'm pretty good. I'm remembering this stuff. New Bond, 1984. 40 years ago. Man, I am on a roll here. Yeah, so Tagami showed a case of an OF restoration that was 40 years old using caries detecting dye and New Bond and a chemical cure composite. And so that chemical cure composite gives a little stress relief, not as much as the biomimetic techniques that we've presented in these lectures. But still, when Tagami showed that, he was not aware that the biorim of the whole tooth was intact. Now, Tagami obviously is a friend of mine. Tagami has his name on maybe 400 published articles. But the idea is that cracks do happen in Japan, cracks do happen around the world, but these 50 countries where we've lectured or our ambassadors have lectured, we have pointed out the fact that dissecting cracks can save teeth and prevent the sensitivity that teeth have when a crack is propagating. That shouldn't have been new information, even 40 years ago, because the science of cracks started in the 1850s, not the 1950s. The 1850s, engineers were approaching a scientific evaluation of why things crack. Now, wood is different than metal. Metal is different than composite. I mean, all these things, the materials that crack under function, they vary. But the engineers aren't anything but, smart people. I mean, they're trying to think of things that can help us not have airplane crashes, car crashes, and even tooth failures. So the engineering literature that Davey and I were introduced to by Dennis Groh and other engineers that we've talked with, and then we read the books, and all of a sudden, even some of the books refer to teeth in these terms of isotropic, anisotropic, and we talk about crack initiation, crack stopping. Well, once we use the engineering terms and the engineering concepts, that is a part of biomimetic dentistry using the 6 lessons approach. Unfortunately, unless the 6 lessons approach isn't being used, then the biomimetics will not understand cracks and will try to bridge a crack, which is a popular phrase around the world. People are using adhesive dentistry. They think we'll just bond over that. Unfortunately, the literature says if you bond the top, but you still have a crack in the bottom, the forces of the whole tooth structure, as they start having these micro movements, concentrate right where the crack tip is. It's a concentration of micro movements, and the crack keeps going. I mean, that's just the scientific fact. If a dentist doesn't know it, it just means he doesn't know the science. Now, who's responsible to get the science into the education of the next generation of dentists? That's a big question. And I'm going to look at the camera again and say, I hope it's not just me, but right now the universities that are teaching biomimetics are teaching it through faculty members who have been trained outside of the university. And those universities that have Davey, myself speak, and other of our masters speak, they're all over the world. But to embrace that and to get that into a curriculum, it's a big investment. You have to train all the faculty. Many faculties of the United States will have 100 full-time faculty members and 200 part-time faculty members. To get them all on the same page and to get them all calibrated, it's a lot of effort and it costs money. And there's no university in the United States that does that right now. Now, maybe biomimetic dentistry takes more than a 4-year training as a dental student. Maybe it takes an extra year. It's possible. But I believe that every dentist in a year of training in dental school can become a biomimetic master. You just have to have the faculty that are trained. So that finishes our lecture on biomimetic dentistry. And we hope that that clarifies some of the difference between minimally invasive dentistry adhesive dentistry, cosmetic dentistry, biomimetic dentistry. And until next time, get bonded, stay bonded.